Okay, very good. So, hi everyone. So let's start. This is sixth lecture in our advanced calculus series. So over the weekend, I gave you, I guess I gave you two problems, right? So let me just do now the first one, maybe the second part of the first one, which covers everything basically. So if you remember, so this is a weekend problem. Just for the warm-up, let's do this. So you remember a line was given to you in symmetric form, right? So there was a line, x minus 2 over 3 equal to y plus 1 over 4 equal to z over minus 1. And the point M, which was 2, 1, 1. So this is a line. So let me just, I'm not drawing this line vis-a-vis the coordinate axis. I'm just drawing a line, right? Just the usual, just a line. And there's a point M outside. And the first part was to find the distance from M to this line. Obviously, we have to use that formula that I gave you, but and I proved to you. But then we have to choose a point P to find the distance. So this was the distance that was in question. Then the second part, which is quite related to the first part, was to find the equation for all those points that have constant distance 2 to the line, right? Points that have constant distance 2 to the line. So what are those points, first of all, geometrically? Do we know what those points are? I mean, yeah, it's a tube. In other words, it's a cylinder, right? It's an example of a cylinder, a tube, right? So, so the question was this: find the equation of 4 points M equal to, so this is M. Now I'll just write x, y, z. Such that the distance from M to this line L is equal to 2. Obviously, as I said, I mean, it was also mentioned that the set of all those points is a cylinder or a tube that's built with center at L, right? So you just have to take make a cylinder. The center line is this L, and your M should be somewhere on this cylinder, but nothing else. So on and so forth, right? So first of all, this is a cylinder. But this is the geometry of the problem, so it means that we have some idea. So I have two comments. I guess they are solving the problem, so there are solutions. 3 points form a plane, and what is the line that contains another point orthogonal to the point? So for the 3 points, we think about it later. Right now, we are doing the first problem, which is about this distance to a line. That was the first problem. Okay, very good. So now let's do that. So we want to find the distance from this point M to the line, and we want to make sure to find just those points whose distance to this line is fixed among 2. Right? That's what we want to do. Okay, so we have to pick a point P on the line. Now, this point P can be, well, I've already chosen, can be anything. So can you tell me a point on this line, and how would you go about finding a point on this line?
2, -1, 0.
For example, this would be a sure bet, yes, 2, -1, 0. But that's not the only point, right? You can have many, many other points. You have infinitely many points. But that would be the easiest one to find, indeed, yes. So, e.g., let P equal to 2, -1, 0. That's good. And then remember the formula for the distance? B was norm of what? PM cross V. So this is the vector PM or NP, this is PM, cross V divided by norm of V, where V was the direction vector of the line, a vector that's parallel to the right? So a vector parallel line. And which vector is parallel to this line? Can you tell me? What can I choose for V? Yes.
3, 4, -1.
3, 4, -1. Exactly. That's ABC. That's the one that we chose to start with, right? Then we were driving the equation. That was it. Okay. So B is equal to ABC in the standard form. That's equal to sorry, 3, 4, -1. So we have two things to do now. First of all, we have to compute PM, and then cross product, norm of this, and then we have an equation. We put it equal to 2. So this is going to be, so this is basically the equation, but we want to get the actual XYZ equation, not just this abstract form. Right? So I can erase this because I have got all the information I needed. So now, what is PM? PM or MP doesn't matter really, it's just M minus P, right? So point M is XYZ minus P. What is point P? P is 2 minus 1, 0. Okay. So this is equal to X minus 2. Y plus 1 and Z. Okay, then we have to take the cross product of PM with V, right? With V. So then this vector PM cross V, remember, we had this formula IJK for this cross product, right? The determinant formula for cross product. IJK. Okay, very good. And then we have X minus 2, Y plus 1, Z. And V, I put, we have V, 3, 4 minus 1. So you should just think of X minus 2, Y plus 1, and Z as numbers, and then carry the calculation of the determinant as usual. There's no difference. This X, Y, Z makes no difference. Right? So this is equal to, so then this is like, we just write 4 times. Now you should watch me because I'm prone to making a lot of mistakes. That's right. So be careful, minus 3 times Y plus 1. The whole thing is I, times I mean, minus, now the second one is X minus 2 times -1. Oh, we have to be careful. This negative 3Z J plus K. Just like this. So first, so this is 4 times X minus 2 minus 3 times Y plus 1. Right? Is that okay? Is there any mistakes here? Can you find any mistakes? No? Hopefully this is okay. So this is equal to, now, this is 4x Let's see.
Yeah.
I made a mistake already. Well, where did it come from? Yes, I have to do it. This is total nonsense. What am I thinking? Yeah. Sorry. Yeah, this is minus 1 times y plus 1, right? Minus 1 times y plus 1. And then minus 4z. I. Then this is x minus 2 times minus 1 minus 3z. This is okay. Plus 4 times x minus 2 minus 3. So this is hopefully okay. Okay, so this is equal to negative y, negative 1, negative 4z times I. That's fine. Negative x plus 2, negative 3z. J plus, then we have 4x negative 3y, 4x negative 3y, then negative 8, negative 3 is negative 11. Okay, this is my vector now, right? This is the vector, good. So now we just have to compute its length and divide by this length. Okay, so let's go to this last step. So what is its length? Tm, yes, cross v is equal to, well, this is the square root of, this whole number has to be squared. So this is 4z minus y minus 1 squared, 4z minus y minus 1 squared, plus x minus 3z plus 2, or actually negative x, negative 3z plus 2 squared, plus there is square root continues here, plus 4x negative 3y negative 1 squared.
Negative 11.
And then there is negative 11, of course. Thank you. Let me see if there are any comments. Yes, I hope there are no mistakes from audience.
In the first one, it should be negative 4z.
I is wrongly put. Where did v equal to ABC? Where did v equal to ABC come from? Oh, okay. So that, yeah, that I was. So what is the question? What's your comment?
So it should be negative 4z, the first one.
Oh, here?
Yeah.
Oh, negative 4z. Where is it? Oh,
In the
absolutely.
I.
Okay. Yeah. Is that okay? Is that okay?
Minus 11 on the minus 1 minus 11.
Then it should be, yeah, there's no minus. Okay? Okay, now there was a question, where did I get this v equal to ABC? Yeah, that's so you see the equation of the line is of this form, x minus x0 divided by a equal to y minus y0 divided by b equal to z minus z0 divided by c. This was the direction line this was v. From previous lecture, you can see that this is v. Is that okay? Should it be minus 4z in the first one?
Yeah,
Oh, then this is already corrected. Anything else? Yes.
Wouldn't in the J, wouldn't that negative distribute?
Negative x plus 2.
One line lower.
Oh,
So
yeah.
it's negative of negative x plus 2.
Negative x plus 2, negative 3.
Yeah.
What is
So wouldn't all those signs flip because that negative has to distribute?
Well, I neglected this negative because if you square it, you're going to get the same. So I didn't put it.
Okay.
But no, that's you could have done it, but you get the same result because a squared equal to minus a squared.
Yeah.
Okay, so I think I've covered myself now against all the criticism. Okay, so and there's no mistakes anymore. So let's push through. Okay, so this I answered. So now, and of course, we need the still norm of v. Again, square root of v. What was v? Do you recall what was v? What was the vector v we got?
2, -1, 0.
So this would be 2 squared. No, they can't be 0. They can't be 0. What was v? Oh, v is 3, 4, -1. So that's like 3 squared plus 4 squared plus 1 squared. So 3 squared, 981 plus 4 squared is 16, right? 9 times 1. 3 squared. 9 squared is 81, right?
Yes.
You're not supposed to know these things, but I'm supposed to know this because your generation didn't. Did you learn a multiplication table?
Yeah.
Still okay. So you're safe. Okay, as long as you learn multiplication table, you're safe. Okay, so this is like 17 plus 81. That's 98. Okay, good. So now, what was the question? What was the equation? The equation was this: norm of p m or np doesn't matter plus p divided by norm of v is equal to 2. So to get rid of these square root signs, we square everything. Norm of pm plus v squared over norm of v squared is equal to 4. That's a good equation. So this means that, so I have this equation now. So finally we get so now I don't want to simplify that. I just want to keep it like this: -4z, -y, -1 squared plus -x, -3z plus 2 squared plus 4x. -3y, -11 squared equal to.
Excuse me, Professor. Sorry to interrupt.
Yes, yes.
But I think there was a mistake when you calculate the norm of v. Like you're supposed to raise 3 to 2 rather than 4.
Oh yes, that's right. Thank you so much.
Thank you.
Thank you. Yeah. So this is 9 plus. So can you tell me the answer? Then 9 plus.
That should be
6.
a 4 as well. So yeah.
Which one is 4?
The middle one.
4 squared.
That's 4 squared.
That's 4 squared. Okay.
I think the answer is root 26. Square root of 26.
9, yeah, plus 16 is 25, 26. Yes, very good. Thank you so much. You should watch me when I do calculations in public, okay? So just watch me. Be careful. Okay, so now we have got this equal to that. So 4 times 26, right? So 4 times 25 is 100 and 104. So this is the equation that we are looking for. Equation desired. Obtained. Right? Okay, so I think that you can all do this question. The only problem was just formulation of the thing. What you're supposed to do, what you're not. So otherwise, you know how to do it because you have all the tools that you right? So now this is an equation of a surface of this cylinder. There is a relation between x, y, z. You can raise this to power 2, but then you don't get something really simpler or more kind of illuminating by doing this. It's just an equation between x, y, z. It's a quadratic equation. We will go back to this sort of equations soon. We'll study that in a systematic way. I think this was a good question. So I woke up yesterday with this question in mind and said, okay, I have to tell my students this problem. So this is the beautiful thing about this new ways of communication. Owl is great, and of course, we had email before, but this is even better. Very good. So any comments or questions about this? No?
Sir, quickly, can you explain why the norm of P or PM cross V, like that entire thing got squared to get 4? Why did we do that?
The norm, you see in norm, yes, in norm there is a square root sign, right? I mean, if you want to compute the norm of vector, say alpha, beta, gamma, it's just square root of alpha squared plus beta squared plus gamma squared, right? No matter what alpha, beta, gamma is. Alpha, beta, gamma here is of the form x, y, z and stuff like that, right? So, but we don't like a square root sign, so we square them just to get an equation which would be like this. Squared equal to alpha squared, beta squared plus gamma squared, right?
Okay, yeah, I see that.
You see, yeah. So that's just a bit of maybe better kind of presenting the result. Otherwise, you could have kept it in with the square root sign. That would be absolutely correct solution also.
Okay, thank you.
Very good. Any other questions or comments? Okay, so now there is this, so we can just move to some new stuff now. Let me erase. So it's the story of 2 lines. So, okay, so it's a bit of the tale of 2 lines. Okay. So a tale of 2 lines. So you see, 2 lines in space, they can have some relationship to each other. Basically, there could be 4 possibilities, right? So 2 lines in space. So let's call 2 lines L1 and L2 into space. Basically, they can be in one of the following 4 situations. And that's it. There can't be anything else. Mutually exclusive situations that I'm going to. Either they are parallel, but not the same. So L1 is parallel to L2, but L1 is different from L2. And the picture we have of this, of course, this is L1, this is L2, right? First case. Second case is that they are the same. I mean, 2 lines can be the same after all, right? They are the same lines. You might complain why, if they are the same line, you call them L1 and L2. Well, this is because of logical possibilities. We have to consider all cases. They are the same lines. So L1 is equal to L2. They really coincide with each other. So L1 is equal to L2. That's second possibility. Third possibility is that they intersect, but they are different. Right? They intersect at one point. Mean exactly at one point. So this is 2 lines L1 and L2 intersecting at one point P. Remember, these lines are not in the plane, right? The lines are in space, so they can be. And the fourth case is that none of these, if you want, none of the above. In other words, they don't intersect and they are not parallel. and they are not the same, right? So they are called skew lines. Called skew lines. So the skew lines picture you should have in mind, of course, it's clear from what I said. This is like L1, this is L2. So the two lines, yeah, it's just like that. They don't intersect, but they are not parallel. They're not the same. So this is possible. So there are only 4 possibilities for these 2 lines. The tail of 2 lines is like this. And now the task is, I give you the equations of these 2 lines. You have to tell me which is which. Are they parallel? Are they intersecting? Are they skew and stuff like that, right? So now the question now, so the goal now is this. Given equations of L1 and L2, find out if 1 or 2 or 3 or 4 holds. Just from the equation, so I have to give you examples of this, obviously. So we have to do examples. Now, let me ask you the following question. Imagine you just choose 2 lines in random in space, right? What would be the possibility? You think it's more probable to be case 1, case 2, case 3, or case 4? Which one you think is more probable? I just want you to give you, I just want you give me just intuitive feeling. I'm not asking about exact definitions or proofs or anything. So you think most probably they're going to be parallel but not the same? Is that? Oh, 4, you said 4. 4. So none of these 3 cases just skew. They don't. From audience, any answers? Yeah, indeed, that's quite reasonable. I mean, I cannot prove it to you because we don't have right concept of probability to discuss this. You have to know a little more probability theory. And honestly, I really don't know myself how to do it right now. So I better not try. I don't think it's going to be a very difficult problem. Yes?
Just show each 2 lines which has intersect or which has intersection there. We can map to a lot of lines which don't have any.
Yeah, I'm pretty sure one of those ideas will work. Right? But I meant to set it up in a very precise mathematical form to define a probability space and to define all these things. So it will take it. But yeah, that's exactly true. Space of 2 lines is more complicated.
No. So the space, the 2 lines inside is only R3 or it can be R4, R5.
Yeah, it's R3 cross R3, space of 2 lines. It's R6. It's a 6-dimensional space.
No. I mean the space, those 2 lines inside it.
Right. No, the 2 lines, okay, so that's it. The 2 lines are inside R3.
Yeah.
But the space of 2 lines is not R3 because you remember I said to fix, actually it's more than, so it is more than R3 cross R3 actually. It's R6 cross R6. It's 12-dimensional space. I'll explain to you. Right? At the beginning of the lecture, I mean, maybe class also for this is a good discussion, by the way. At the beginning of the lecture, I mentioned to fix a line in a space, how many parameters we need? 6, because you need a point and you need a direction. 6 parameters. Okay, so for the first line, you need 6 parameters. For the second line, you need 6 parameters. So you need 12 parameters for 2 lines. So you have to define a probability on the 12-dimensional space. And then we go there. But this was good. Okay, so this was a bit not was my intention, but no, I mean this is I wanted to get to this point actually. This was very good to discuss. Very good. So, but now back to this sort of problems. I guess I can actually now ask questions along these lines. Consider the lines. So now I give some examples. So okay, so to construct examples of this, I don't even have to look at any notes, right? I just take randomly 2 lines and I tell you, prove that they are skew. So if this happens not to be correct, chances are 0 for this not to be correct, by what I said. So I give you some examples. So give me 2 random lines you wish. You pick a line. Yeah, you pick a line. Don't think, just pick a line.
Well, in what form? Just vector form?
In symmetric form, maybe.
Symmetric form?
Yeah.
X minus 2 over 3.
Okay, x minus 2 over 3 equal to
Y plus 4 over 5.
y plus 4 over 5.
Instead over negative 3.
Oh, you know what? I should use that so that the other line, the other person who gives the line shouldn't have seen this, but that's okay. Equal to what?
Z over negative 2.
Z over negative 2. Okay. So now someone else gives me a second line without noticing this.
X
X
plus 1
plus 1
negative 2
negative 2 equal to
y minus 3
y minus 3 over 7 equal to
c plus 2 over 4.
4. Cool. Okay, that's good. So now I ask you to prove that these 2 lines are askew. And I bet I'm not going to lose anything on this but I may lose because there is still a non-zero chance. I mean, there's still probability, but that probability is 0, technically speaking. So show, so this is L1, this is L2. Show that L1 and L2 are skew. If not, then I'm screwed. So that's the thing. Okay, how do you do that? Also, the class, I want the class try this. How do you do this?
They are not parallel, they have no function.
Yeah, we go one by one. Yes, so solution. You ask yourself, are they parallel? Are they parallel?
No.
No. Why no? Because the direction, exactly, because direction vectors is 3, 5, minus 2 is not parallel to this vector minus 2, 7, 4, right? Since 3, 5, negative 2 is not parallel to negative 2, 7, 4. So they are not parallel. In particular, they are not the same line either. So there are only 2 possibilities left, right? So just 2 possibilities left. So either intersect in a unique point, in just one point, or don't intersect and they are, and hence they are skew lines. So now I want you to prove that these 2 lines don't intersect. I'm not totally sure, but I'm 100% sure. Okay, something like that. So show these lines do not intersect. Oh. So how can you do that? How can we show that these 2 lines do not intersect at all? We have to consider the equations And then we have to show that those two equations don't have a solution, right? So what is the equation here? So let us write the first line. Let's take this equal to t, and this one equal to s, right? So the equations is going to be like this: x minus 2 equal to 3t, y plus 4 equal to 5t, and z is equal to negative 2t. The second one, so this is line L1 in parametric form now, and the second line is L2 is x plus 1 is equal to negative 2s, right? And y minus 3 equal to 7s, and z plus, what was this? Z plus 2, or what did you choose?
1.
1, okay, yes. Z plus 1 equal to 4s. Okay, why did I choose different parameters t and s, by the way? That's a very important point. Why did I choose different parameters? Why didn't, because I told you before that the equation of line in a parametric form is going to be this equal to some t and then is equal to t. Now I'm using t here, s over there. Why? This is a very, very important point. From class or from audience, home?
Because you don't know if it's the same, right?
Exactly. We don't know they reach to each other, if they ever reach at the same time. But it doesn't matter. We are only interested in same point, not same time, right? So you want to meet someone somewhere, not that, but you want to just meet that person at that point, not at the same time. So that's a strange kind of meeting idea, but that's okay. It's not usual meeting that people do. So this is L1, okay, this is L2. So this point, different S and T. Different S and T. Okay, so, but then this is L1, this is L2. Oh, I should actually look at chat. For skewed. Okay, so yeah. So I have a lot of guesses for skew, but I want to because we have to do it now. Yeah. Yeah. So someone said almost always. Yeah, it's right. So now we have to put x y z equal to x y z from here to there, right? So here we get x is equal to 2 plus 3t. This is x equal to minus 2s minus 1. And y for the second one is equal to 7s plus 3. Oh, what am I doing? Y equal to 5t minus 4. Shoot. 5t minus 4. Can I do first one? 3t plus 2 equal to negative 2s minus 1. 5t minus 4 is equal to 3 plus 7s. And then the last one, z, is equal to negative 2t equal to 4s minus 1. Okay, now the task is the following. To see if this system of three equations in two unknowns has a solution or not. So these are three equations in two unknowns. Does it have a solution? Does it have a solution? So number of equations is more than number of unknowns, right? From linear algebra, for example, 1600, whatever, or common sense doesn't have to, you don't have to know even anything, right? if you have too many equations and few unknowns, you can try to solve some of them, but then you run out of variables, but you may still have a lot of equations to solve. So that's very hard to solve these equations when the number of unknowns is less than the number of equations. So chances are that this won't have a solution, and then we have shown that no intersection point. So let's try to do that. So we want to show no solution exists. How can we do that? How can we show that there is no solution? Well, one way, there are many ways to do it. One way is to solve two of them, find S and T, and show that it doesn't satisfy the third. For example, that would be one way. So let's solve the first two. Possibly we can solve the first two. So it's 2, so let me write it. We have got 3t plus 2s. 3t plus 2s is equal to -3. And that one is 5t minus 7s is equal to 5t minus 7s is equal to 7. So these are the first two equations. Right? So these are the first two equations. Okay, so now, well, let's solve this. I mean, how do you solve it? Just multiply by 5, by -3, so we get 10s here, I suppose, plus 21s equal to -15, -21. So we get 31s equal to -15, -21 is -36, right? So S is equal to -36 over 31. So what is T? T is equal to, oh, did I find S? Yeah, S is that one. T, to find T, I can either sub into any of those, or also I can try to cancel S. Let me cancel S this time. That's for me is easier at least. Multiply this 7, multiply by this 2. You add, then they cancel. So this is 21t, right? Plus 10t. Suspiciously looks like the other one. It's 14. So this is 21 now. T equals to 14. T is equal to 14 over 21. So T is 14 over 21. So 14. Are we okay with this calculation so far? This looks okay. So there are 3 comments. My God. Yeah. Okay. Yeah. Very good. So we found. So yes. Okay. So there are some answers. Very good. Now what? Now what we can do? What can I do now? So I've got T and S. I have satisfied the first 2 equations. Now, do they satisfy the third guy? No. But these do not satisfy. The third equation. So it means that these 2 lines do not intersect. You proved it beyond any reasonable doubt that these 2 lines do not intersect. So the lines are askew. No intersection. Lines are askew. You see, I did not think about this problem before. I just, you randomly chose these things, and then the result was what we expected. It's very hard to, you have to do a lot of matching and see that, I want to match this with that for lines to not to be skewed. So it's a 16-dimensional space, right? Question? Question from audience? Home audience? No, okay. So we have 5 minutes. Now what we want to do, we want to go to the next section, which is equation of a plane. So that's so we did some examples today. But this was new stuff. So equations of a plane. If you don't have any questions about skew lines and stuff, I go to planes. You're good? Okay. So there was one comment. T should be, oh my God. T should be -7/31 as -7/31. T. What?
Yeah, I got the same.
-7/31?
-21/93. Oh, like, yeah.
Yeah, thank you. Anyhow, it doesn't satisfy the third equation, no matter what. So this one would also be okay. Yeah, thank you so much. Yes, absolutely right. Yeah. Okay, so my computer sometimes, most of the time. Okay, now, actually, so yeah, we can have a few minutes just equation of the plane. So I don't know which section, this is maybe section 2.6 or something in your book. So equation of plane is interesting because you have this plane now. By plane, we mean, of course, straight, flat plane. What we need to fix the plane are two things, right? So we need a point on the plane and a normal to the plane, right? If you give me a point on the plane and a normal line, given P belonging to plane and N normal to plane, the plane is fixed. I mean, there exists a unique plane that passes through this point and is orthogonal to this line. That makes sense. That's reasonable, right? That just makes sense. So then, any other point Q on the plane satisfies this equation that this vector should be orthogonal to this vector. So the equation of a plane in vector form then is of this form. So for any Q belonging to plane, you have the following equation: PQ is orthogonal to N. So this means PQ dot N is equal to 0. And this is equation of a plane in vector form. So what remains to do after this step is just to unpack this equation. So we should just unravel this equation and see what kind of implications it has in other forms. That's what we did also, by the way, with line, right? So now before moving there, let me ask you a question. How many parameters do you need in order to fix a plane in a space? How many parameters we need? 12? Really? Yes.
Also 6.
Also 6. Yeah, stands to reason. Yeah, also 6. Why? Because you need 1 point, which is 6 parameters. Oh, sorry, three numbers, 3 parameters, and this vector n. Is it really 6? I think I made a mistake.
If you use 2 factors, the difference is
9?
if you don't use that n to fix this, then but instead use two vectors to fix the plane. It suffers.
I think no, it's not 6. Actually, it's 5. Yes, it's. I think it's 5 really. So let me. Yeah, I think it is 5. It is 5. Or is there any answer? Maybe. Actually, my answer for. Oh, sorry, 3, 9, 4. Oh, I have all kinds of answers. None of them. I was wrong also, by the way. It's 5. Why is it 5? I give 50 cents to correct answer. Okay, maybe $1. I raised.
Does the normal only need 2 parameters?
Yeah,
Oh, wait.
because normal is just the direction, right? The size, I mean, the length of that vector doesn't matter. You can always pick it to be norm 1, actually. It doesn't matter if it is the whole. I mean, we don't need 3 numbers to fix that direction. We only need 2 numbers to fix that direction. Because look, directions are on the sphere, right? I mean, this is really the space of normals. It's 2-dimensional. So you have 2 dimensions for n, 3 dimensions for p. P is 3. I mean, it's not negotiable. I mean, there are 2. So it's 5. So my thing about 6 parameters for line to start it was also wrong. Right? It's 5 parameters. Because you have 1 point on the line and then the direction. The direction doesn't matter which, it just needs a direction. 3 plus 2 is 5. Space of lines is 5-dimensional, and space of planes is also 5-dimensional. Till next notice. So this is correct. So this is what we have to discover things as we go on. I mean, we should not just take anything at face value. We have to think. Okay, guys, thank you so much. So we just stop the video right now, but I'm here and you can ask your questions. So let's stop the recording. Okay, no, stop recording.